using the so-called lamps. And when the lamps comes in contact with the methane gas, so the explosion was happening. So in 1912, in Europe, there was first, and then after there's sometimes of this explosion happening in mining, they started to use the technology of this protection and hazardous areas started. So the miners were using the so-called Davy lamp. So this lamp was consisting of a lamp with the frame enclosed inside the mesh screen. So the screen acted as the frame arresters. So when the air came in contact with this frame, it could not pass through the mesh, so that could support combustion. But the holes of those mesh were so fine to allow the frame to propagate through them and ignite. They could not ignite that fire damp. But so the science of explosion from 1900 up to 2014 increased so much because of the technology happening in the world. Let's see this overview in Europe and United States. In 1912, the first standard explosion protection types was introduced. And coming to 1920, National Electrical Code implemented equipment in extra hazardous location. Coming to 1928, in America, they introduced the so-called material classification. So what kind of material were used in industries and so far and so forth. In 1943, even that was before the World War, the first rules for construction of electrical equipment used in explosive areas were started in Europe. Coming to 1947, America, they started to introduce a class and division system, which are two systems used up to now in the world. In 1971, United States introduced the temperature class because different materials ignite in different temperature. So in 1971, they started to classify or to define temperature which can ignite different materials. 1975, in Europe, they started to harmonize national guideline in Europe. And 1994, there was ATEX. This is directives in Europe. They have different countries, so they started to use the same directive in all Europe, so they can sell equipment in all Europe, across the Europe. 1996. So now the world was talking. They wanted to talk in the same language. So before in United States, Mexico, and Canada, they were using this they call class division system. And now, because the world was using class and zone systems, so in America too, they started to adopt the class and zone system. In 2007, and now came this worldwide unification guideline, that is IEC EX scheme. So this is International Electrotechnical Commission, in which the world now can use the same. They have this testing and certification of the device used in EX areas or in explosive areas, so they can be sold worldwide. And IEC started before 2007, but in 2007 they started to organize or to unify or worldwide standard in equipment used in these industrial areas. So after seeing this, so now let's see these areas, hazardous areas. So this is an area in which explosive gas atmosphere or in which explosive atmosphere may be present or maybe exist in quantities as to require special precautions for the construction, installation, and use in this equipment. So if you have an area, especially this industrial area, and there is existence of this explosive atmosphere, the equipment used in these areas must be explosive approved. And so see these areas, we call them hazardous areas. Where can we find these hazardous areas? Hazardous areas can exist in mining industries, where we can find the flammable gases, that methane, flammable dust, coal dust, and so forth. In oil and gas industries, then you can find flammable gases, liquids, and in chemical industry too, we find these explosive atmospheres such as flammable gases, liquid, and salts. Energy production, painting industry, metal processing, where you can find dust and fine particles. Woodworking areas, agriculture, where you can find biogas, disposal industries, recycling industries, and foodstuff industries. People, they normally don't understand this foodstuff industry too. They can exist these explosive materials such as flour, sugar, spices, rice flour, and so far. After knowing this explosive areas or where this material can be found, so now let's see this explosion of fire. Explosion of fire is sudden chemical reaction of combustible substance with oxygen. This will involve the release of high energy, temperature, and pressure. Combustible substance and oxygen must be in sufficient quantities to support explosion. And when they encounter ignition source, so the explosion of fire will happen. So in order for an explosion to occur, three factors must be present, but these two factors, flammable substance, oxidizer, must be in sufficient quantities. So when we are talking about flammable materials, what are these flammable materials? Flammable materials are materials which can be gas, liquid, or solids. For example, in this gas, acetone, is good example of flammable materials. Propane, carbon monoxide, and oxygen. Liquids, gasoline, acetone, ether, pentane. Solids in plastic, so plastic industries, wood stuff or wood dust, fibers, fines, metal particles, and oxidizers. Two, we have three types: gas, liquid, and solids. Good example of oxidizers. Gases is oxygen, fluorine, chlorine. Liquids, we have hydrogen peroxide, nitric acid, chloric acid. Solids, we have metal peroxides and this ammonium nitrate. And a good example happened in Beirut. And ignition source, we have heat, sparks, flames, and other source of ignition. What can be caused, maybe, for example, caused by electrical equipment. For engineers, you must be familiar with this fire and explosion. For example, you have to know the properties of the materials present in that area, the nature of explosion processes. Then after knowing this, you come across with the procedures to reduce fire and explosion hazard. So, as we said before, for the explosion of fire to occur, we need three factors: heat, oxygen, and fuel. Oxidizer, flammable materials, and source of ignition. Removing one leg of these three factors, explosion of fire will not occur. But fuel, oxygen, must be in sufficient quantities. So what we mean when we are saying sufficient quantities? For this explosion to occur, the concentration of air and concentration of combustible materials, of flammable materials, must be in explosive range. So this range is we have two ranges, limits. We have lower limit, upper explosive limits. When below lower explosive limit, the mixture, what we call it, the mixture is too lean. It means much concentration of the air in the mixture. And below this limit, no combustion will occur, or the combustion will propagate in difficult. And when this mixture is too rich, means the concentration of combustible substance is more than air concentration. So here we call the mixture is too rich, and partial deflagration with all the flame will propagate in way that it cannot provide sufficient concentration to cause explosion. But in this range, we call it area subject to explosion. We call it explosion limit. explosion limit. And we have here they call partial deflagration. Explosion is defined in two. There is these two terms: deflagration and detonation. What are these? Detonation and what is deflagration? Detonation is when the speed of the propagation of the fire is supersonic. We call it detonation. Or if the speed of propagation of fire or explosion is subsonic, we call it deflagration. Let's say here we have example of these materials. We have, for example, acetylene. The lower limit or lower explosion limit is 2.3, and the upper explosion limit is 78. And this, we measure it in volume percent. So, for example, if you have the concentration of this mixture, or the is, let's say 2, is with this explosion cannot occur here. And if it's between this 2.3 and 78, this area is subject to explosion. And upper explosion limit, then we don't have this explosion. So coming ethane, petrol, benzene, natural gas, heating oil or diesel, methane, propane, all of these, they have lower and upper explosion limit. So see here, we have different explosion limits. So the material with a small range of explosion limit, these are not so much hazardous than when the material has a range of limit is very high. For example, 2.3 and 78. We have very large area subject to explosion, and this material can be more dangerous than, let's say, for example, propane 1.7 and 10.9. So in industrial area, the aim is to prevent the formation of ignition. But how can we do this? Then there are measures to take so that to prevent this explosion to occur. We have 3 measures to take so that to prevent the formation of ignition. First, we prevent explosive atmosphere. And this we call them, we have primary method and tertiary method measures to avoid ignition. And if we can't prevent explosive atmosphere or avoid ignition, then we have to limit the effects of an explosion to a minimum level. So we have primary measure to prevent an explosive atmosphere. How? Ventilation system. So we use ventilations to neutralize or to remove or to decrease the explosive atmosphere. We can use natural ventilation or artificial ventilation. Gas detection system to detect if there is presence of explosive gas atmosphere. and then we can take measures to remove that effect. Addition of inert material to a device. So the device is inerted with materials to prevent introduction of combustible materials. This is to decrease the use of combustible materials. But in our industries, you can't have an industry and you avoid the presence of substance or flammable materials. And in secondary measures to avoid ignition, how? Here we employ protective measures against ignition. We classify materials, we can classify areas, and classify devices, and we can define or classify acceptable temperatures. What kind of ignition sources do we have? Hot surface. In that industry, you have to avoid the hot surfaces, to use surface which are not hot. Electrical arcs and sparks mostly happen in most industries. People blame that arcs and sparks, they can cause explosion. Atmospheric discharge, this is lightning. Mechanical sparks. So to avoid using tools which can create sparks and cause explosion. Chemical reactions, open flames, electromagnetic radiations, and optical radiations. So classification of areas. What is these areas? If we analyze and classify environment where explosive atmosphere may be present, and if that area we facilitate proper selection and installation of equipment, especially electrical equipment, to be used safely in that environment, that we call it area classification. On classifying areas, first of all, we classify materials. An engineer, you have to know the type and characteristics of that material present in that area. For example, in industries, most industries, you have to know the material present in that areas. And that classifying materials, we categorize them into 3 types. Gases and vapors, we call them class 1. Dust and particles, we call them class 2. And fibers and fines, we classify them as class 3. After classifying those materials, so gases and vapors are subdivided into small groups: flash point, ignition temperature, temperature class. What are these flash points? Normally, in a liquid, or flammable liquid, if the temperature will cause vapor in the surface of that liquid, that temperature, the lowest temperature to cause that vapor, we call them flashpoint. And that vapor, if could encounter ignition source, it would explode or ignite. So that is flashpoint. Ignition temperature. So this is minimum temperature at which flammable material or explosive atmosphere would ignite. Temperature class. So this is temperature of the equipment or the surface temperature of the equipment. So the temperature of the equipment, surface temperature of the equipment must be lower than ignition temperature. So the equipment could work properly in that area. Smoldering temperature, ignition temperature in class 2, and minimum ignition temperature. Smoldering temperature is the we can say self-ignite temperature of the layer of the dust, because here we're talking about dust and particles. And ignition temperature, as we said before, is minimum temperature for the flammable material to ignite. And fibers and fryings, so we have class 3. These two can subdivide it into 3 groups. After knowing the material which are found in that area, and then we have to classify that area or to classify the equipment to be used in that area. Then here we have 2 groups. We have group 1 and group 2. Group 1 is equipment used or equipment which can be used in mining industry, susceptible to firearm. Group 2, if the equipment can be used in other than mining industries, this we call it on surface or in other industries than mining. And group 1 subdivided into 2 groups, M1. So M1 is when we allow the device to remain energized during the explosive atmosphere, and then we call it M1. And M2 is when we allow the device to be de-energized during the presence of atmosphere. Group 2 subdivided into 2, G for gases and D for dust. Group 2, remember, is gas and dust. These are maintained as separate areas. Each area has 3 categories, and these categories are designated as zones. What is these zones? So, zone describe the amount and duration of material present in that area. After knowing the presence of material and amount, so say here we have zone 0. This first number after zone 0, zone 20, zone 1, 21, 2, 22. Zone 0 is when as we said, that zone describes the amount and duration of material present. So if the material present in this area and the duration of that material to be present is continuously or frequently or remain for a long time, then we call it zone 0. And this, as we said, is a gas or vapor is zone 0. And for dust and particles, fibers and fryings is zone 20. And if the material, say here, in this car, tanker, we have vents moving away from the substance or flammable materials, or in this, around these vents, we call them zone 1. So it can be defined as zone 1 is the area where material or explosive material are likely to be present under normal operating condition. And zone 20, moving away from the material more far, zone 20 is where we say is when the material of explosive material present are not likely to be present under normal operating conditions. We call them zone 2 for gases and vapors, and zone 22 for dust and particles. Or if that material can be present shortly for a very short time, then we call them zone 2 or zone 20. After classifying materials, classifying areas, now we can classify device, and that will tell us where, in which material the equipment can be used. So each electrical device aimed to be used within an explosive atmosphere must be EX approved. And each device approved can be for use in category. So the category number defines or tells us in which explosive zones the device is allowed to be used. So you can see the category approved for gas. Let's see, this one can be used in all zones. 2G can be used in zone 1 and 2, and 3G can be used in zone 2. The same as dust. 1D can be used in 20, 21, 22. 2D can be used in 21 or 22, and 3D can be used in 22. So we know now what this material and what is the equipment, and we know the zones. So let's see temperature class. Maximum temperature class. But before this, watch this. When, as we say, dust, we talked about dust, we talked about gas. See here how this explosion occur. As we said, explosion can occur when flammable material combined with oxidizer insufficient quantity of this mixture and encounter an ignition. So explosion of fire can occur. But see, at the beginning, we see that when it was open, there was fire. And when we enclosed this experiment, enclosed in a house, and what happened was explosion. So the explosion to occur, at least content of the oxygen must be maybe 20%. Yeah, too much oxygen, or if there is no oxygen at all, explosion cannot occur. So this was gas material. And what about this dust? See silos, some kind of rice mills, flour mills, and refineries, sugar refineries. You see, confined inside. So explosion occur inside that, what do we call it? Inside that, for example, silos, inside silos. So the temperature played a great role for explosion to occur. Temperature plays a great role for explosion to occur. So we are talking about here, we are talking about temperature classification. We are not talking about ignition temperature or flash point. We are talking about temperature of the device. See, let's think this is the device. This is the device. And this is a ambient temperature or environmental temperature, or the temperature in which this material are available. And we have this surface temperature, TO, surface temperature. So the maximum temperature of the device, and TM, internal heating temperature. So this is internal temperature of the device. And if temperature TO exceeds the TA or ambient temperature of the surface, if the place contain explosive material, what will happen is explosion. So the temperature are classified into 6. So here we are talking about International Electrotechnical Commission standards, but a National Electrical Code standard, they extend these temperature classes. We have T1, T2, T3, T5, T up to T6. And here we have ignition temperature of material, and this maximum surface temperature of the device. So if, for example, T5, let's say T5, the maximum surface temperature of the device is 100 degrees Celsius. If so, this device can be installed in a temperature class 4, 3, 2, or 1, because T4 is higher than T5, same as T6. So T6 can be installed in all areas. For example, in areas which contain or has ignition temperature of 100 degrees Celsius. And here we can see how that works. So after knowing the temperature class, so now let's see the protection methods used and electrical equipment marking. But here we are talking about International Electrical Commission standards. So there is National Electrical Standard that can be used in United States, Mexico, and Canada. And IEC is harmonized standard, so it's a worldwide standard. We have type of protection, thematic, and basic principles, and which standard reads as, for example, general requirements. This IEC 60790 tells us minimum required standard for the device used in our industries. We have increased safety. This applies to the equipment or its component parts. So this is applied to the device which can prevent sparks and hot surfaces. If you leave this standard IEC 607.917, then it will tell you what the requirements for that type of protection. Frame-proof enclosures. So the equipment can be enclosed in inside this enclosure, and this housing withstands the explosion. So the explosion can occur, or this allows, or somehow, if the explosive atmosphere are inside that enclosure and explosion occur, so this enclosure or housing withstands that pressure, and explosion will not be propagated outside the enclosure to cause explosion. So that standard IEC 607.911, pressurized enclosure, P. Here is the ignition source is surrounded by a pressurized protective gas. So here we keep positive pressure so that atmosphere cannot enter inside that enclosure. So International Electrotechnical Commission standard 607.992 tells you the minimum requirement for the enclosure or pressurized enclosure. Intrinsic safety. This limits the energy in the circuit, and the formation of sparks or arcs is prevented. We have type of protection, oil immersion. So the equipment which can cause ignition are immersed in oil and separate the explosive atmosphere. Sand fillings, encapsulation. So these protection methods are divided. For example, oil immersion type of protection can be used in zone 1 or 2. Sand fillings can be used in zone 1 or 2. Encapsulation can be used in zone 0, 1, or 2, and are designated as M1, MA, MB, MC. So we will see. And protection type N, this can be used in zone 2. So after knowing all this, let's say here we have symbol or example of how these markings are made. So we have epsilon X. So this tells us that the equipment complies with European standard. We have here two. These two, Omanic 2, tells us that this equipment or equipment type or group or apparatus group 2. We said group 1 is for mining industry. Group 2 is for other areas than mining. And here we have 2. As we said before, this is category. So the category tells us which EX zones this equipment can be used. 2, as we say, can be used in a zone 1 or 2. And we have G here. G tells us that this equipment can be used in a gas or vapor or mist. EX is the equipment is explosion protected. We have here DB and EB. DB and EB. D tells us the type method of the type of equipment protection. So we have D is flame proof. B tells us which level protection. B, if we have A is for very, very high level protection. B is high level protection, and we have C is normal level protection. And we have E, method of protection 2. E is increased safety, type EB. B is the level protection is high level protection. We have 2C. This tells us this nature of the gas. So we have 3. 2C, 2B, 2A. 2C are those very, very high explosive gas. For example, acetylene and hydrogen. So this equipment can be used even where there is ethylene, there is propane. This equipment can be used. T5, temperature class T5. And we saw that in temperature class T5 is 100 degrees Celsius. So that equipment can be used in a place where the ignition temperature of the surrounding is maybe 120, 135, 450, and so far. And G tells us that is gas, and B is level of protection. So mostly what we have been talking, here tells us that the equipment can be used or installed where gas, vapor, or mist can be found. And here we have the assay type of label or marking. This, and second one is tell us the equipment to the EXT type of protection method construction. 3C. So this tells us this equipment can be installed in a gas, vapor, mist, or dust. And 3C is combustible dust. For example, magnesia, up to temperature 100 degrees Celsius. D is dust, and B is level of protection. And here too, it tells us here we have this temperature. So in order for equipment used in industries or hazardous areas, the temperature must be more than minus 20 to 40. If the temperature exceeds the range of minus 20 to 40, so this label must be provided, and the equipment must be EX approved equipment. And here we have IP. So this is ingress protection, and this talks about dust. So see some examples of these enclosures. Here we have frame proof. We have intrinsic safety. I. Here we have increased safety, pressurized, and here we have a frame proof. In frame proof, we can see here there is this thread. What this thread do? If explosion occur inside that enclosure, this quenches this, and the gas coming out is not so hot to cause explosion. I think for today we can end up here, and thank you very much. Going back to Steve.
Thank you, John, and thank you for all others who attended. And as we promised that you will be coming now to question. I think for people like Frank, I think they enjoyed it a lot because they can see now, especially electricians, how the marking of instruments, especially in mines, how should be for people working somewhere in gas areas, like my friend Justin can also get some more information. Now we are coming to question. I have a question from Elton. Does the training provide certificates?
I think this information, Steve, you can provide them. But in short, this training webinar doesn't provide certificate. This is introduction, but for the certificate, we have to go more than this training. Maybe Steve, you can add more information about that.
What I can say is because as we said, this is like an introduction. The real training should take at least 3 to 1 week, which you can say 5 days. And after that, then we do have some examine. Test. If you pass, then you get a real certificate. But otherwise, if you come to attend those training of ours, which I think will be conducting at the beginning of next year, then from that you just get a certificate of attendance. If you pass test, then you get a certificate which really is valid for 5 years. Many companies worldwide they just give for 4 years, but our company also they give for 5 years. Why they do that? Because this is standard, they keep changing. So they just give you for 4 or 5 years, so that when there will be a new technology, you should also be up to date on that, because you may think you are still up to date, but what you know or what have been it was there during the time you are training, it have already changed. So they that's why the certificate, if you do test it, valid just for 4 years or 5 years for our case. Usually this training worldwide, if you do, let's say in Europe, they are very costly. I think it should be around 2,000, 3,000 US dollar if you do for 1 week. But since you will be doing this in Tanzania, I hope all of you are Tanzania. If there is anybody from out of Tanzania, as I can see here, Mauritius, I don't know, please contact us and we can see how we can organize, let's say, because for us to come in Mauritius, then the training would be a little bit cheap. So we'll be informing you all the time when we will start organizing this type of training. The second question, I think, Elton, you get me about certificate. Otherwise, please, let's be in contact and we'll be giving you more information about our training, because we are here for you guys. The second question is from Alex. Hello, John. There are electrical installation material like Mylar, which are covered by metallized polyethylene, MPET film, which has been tested that they are basic propagators of fire when ignition happens, and is still in use today in most electric wires manufacturers. What can be done to solve the problem? Is there any material that can replace MPET?
Thank you for the question. I'm not quite sure, but I think there should be the way out how to prevent that propagation, or there are some materials which can be used instead of those materials. But I think, Steve, maybe that question, if I could get it well, I'll be able to answer maybe in person the guy who asked.
Yeah, actually,
if you can send me that question, I'll be able to answer him perfect.
The in chat actually is Alex, and please, Alex, we'll come to you back. Let us contact you with the headquarters to get more information about your question, so that we'll be giving you the real good answer and not just what we think. Coming to let me jump first Francis L and come to Justus Estimo, if I've not mistaken your name, please. Sorry. It's from I can see here Mauritius. Kindly share the slides. Yes, we are recording the whole session, and after that we'll put a link in our website. And since you all of you put emails, we'll be sending you the link of YouTube. So all the training today we did, we'll find it in YouTube by the link which we'll send you. So please don't worry about this. we already prepared, and you, all of you get the link. And if you have sometime many questions, please, we should be in touch, and we can be providing you with more information, and even giving the date when we'll be doing this type of training, which you can give certification at the beginning of next year. Coming back to Francis, Francis L. Very nice and informative topic. Can I ask, does the training provide a certificate? Yes, as we said before, it will be just the same answer. This is just a webinar, and actually we are doing for just one hour to give you exactly what we talk, because when we meet many people, we tell them about explosion safety. They always think about fire safety. So what we want is to introduce to you guys the difference between fire and explosion, so that when we'll be talking about explosion, you exactly know what we are talking about. And if you just, I've been telling many people, if you just take your Google phone and Google viwanda vilivyolipuka, just to see how many industry in Tanzania have been caught in fire or some explosion. And many people, they don't know exactly why it happened, but it happened because many people, they take fire safety only. They forget about, or they don't know about explosion safety, which is more dangerous and very important. So this was just to give you the simple picture how these things they differ. And we hope when we organize the more training, the one probably in January or in February, then when you guys come there, you will get more information about this. Alex, thank you, Steve. I'll be waiting. John?
Yes, I'm here.
We should, I think we should prepare the answer and send it to Alex. I hope Grzegorz also will help us.
Okay, Steve.
Yes.
There is here one question from Justice, I think.
Yes.
Estimo. He asked the different. Have you seen?
Yes.
Yeah.
It's an addition question. Okay. From Justice Estimo, there are electrical fitting rated EX and IP. What is the difference in terms of ignition risk in explosive, flammable environments? Okay, to you, John.
Okay, here, as we say that when the last slide, we said that in that table of assay, there is some.
John, can you go back to that table if you can?
Yes, this table of assay. If you look well, there is place where is written IP66, and EX. This IP, EX means explosion protected, and IP is ingress protection. So there are these numbers, two numbers, first number and second number. First number indicates the protection from falling bodies. For example, dust, and the second number indicates that is protected from water. So these numbers, because today time is we had only 1 hour, so maybe next session we talk about dust and dust protection. So the difference is that EX is explosion protection or explosion protected, and IP is ingress protection. Mostly this equipment used in a dust in a industry or in dust or yeah, dust particles. Yeah, something like that. Yeah. So that is, and when you talk about of risk in explosion, risk is that probability, or zones, risk of protection, or risk, yeah, zones, something like that. Yeah, that is a different. We have dust, we have gas, vapor, and mist, and then we have fibers and flyings. So that is the difference.
And what the difference between EX and Explon X?
EX and EX is explosion protected, and epsilon X is that equipment comprised with dielectric, European direct standards, or in IEC, International Electrotechnical Commission.
Okay.
Yeah, that's CE, CE, whatever. Yeah.
Justus, is that okay for you with that question? Please, if you have any question or any addition, please just keep asking us, and we'll give you the answer now because we'll be finishing soon. Alex, and share those useful materials. Yes, we are going to share, brother. We are going all of you to send you through the link through the email you send you give us when you are doing registration. Otherwise, please check in our website. Also, the link will be there. Please share with your friends who maybe they wanted to be here with us, but they failed. But also they can have at least idea what we are talking about. Yes, I can hear Justice is giving us another question. Oh, here there is another question I didn't read from Alex. Thank you, Steve. I'll be waiting. Steve, why don't we have a page in other social medias? Oh, yes, we are going to prepare it soon, whether it will be Facebook or Twitter, because in Instagram it will be too difficult. It always gives problem. It needs you to register. So for anybody who is not registered in Instagram, sometimes it gives you a little bit difficulties of reading this. But we may check if we can have the link in Twitter, because Twitter you don't need even to log in. We'll see the best one, and then we will start soon. But there's another social media already, but it is mainly for us, a group here in Poland. But for us in East Africa, for sure, we'll start soon. Sorry for that. Actually, we should be already started, but I hope within 2 weeks the link should be there. Johnny will work with that. Oh, just say well explained. Thank you. Okay, maybe you have something to tell Justus, John.
Thank you very much.
Okay, I think that is all for today. We are looking forward to have another this type of training, and we'll be just looking for small topic and try to explain about this, because our aim is to put our industry and the working place back home to be more safe, because as you can see, many this type of accidents have been happening and probably will keep going if we won't take measure of this explosion safety. So thank you very much, and we'll be in contact with you guys. Thanks for attending. Please pass this material to others who failed to be here with us today. And yeah, looking forward to be working with you again and again. Thank you very much, John.